Okay, so I'm going to take the sketch from the last video and move it forward to show you how we're going to use this with math. So I've just taken some of the information from the sketch or the animation that I looked at in the video. So we have a function. In this case, it happens to be f at x equals x squared plus 1. It can be really any function. I have a point A, and the purple line represents the slope of the tangent at that point, whatever it might be. So I'm going to call the x-coordinate little a, and then the y-coordinate would be f at a, or whatever I get when I sub the value a into the function. I'm going to see a separate point and call it b in this case, so the blue line represents a secant, not a tangent. But the coordinates of b are going to be whatever this a is, plus a little bit of distance, plus an h. H might be 1, it might be 0.5, but h represents the horizontal distance between the 2 points. So my new x-coordinate for b is going to be whatever a is plus h, and then if I take this x, sub it into the function, f at a plus h will give me my y. Now, because we want this to be a tangent, h is going to approach 0, because 2 points, the horizontal distance as it gets smaller and smaller and smaller, will become 1 point. And as soon as they become 1 point, I am now talking about the slope of a tangent. So if I look at the rise and the run, and this is just a recap of some of what was said in the video, rise over run is y2 minus y1 over x2 minus x1. The video used yb and ya. It's the same formula. I sub in the y from point 2, which is f at a plus h, minus the y from point 1, which was f at a. The x from point 2 was a plus h, and the x from point 1 was a. I can't do anything with the top, but I can simplify the bottom. A plus h minus a just gives me h. So this piece is the slope formula. So now I'm going to combine these two things together, 2 points becoming 1 and the slope formula to get the limit definition for slope of a tangent, which is the limit as h approaches 0 of f at a plus h minus f at a over h. So the limit as h approaches 0 is important because it represents the 2 points becoming 1, and the f at a plus h minus f at a over h is important because it is actually the slope calculation. It comes from the slope formula. So the example I'm going to work through is the one from the video. The function they had was x squared plus 1, and they were looking at x equal to 1. The first part of the video, when I did it numerically, I actually grabbed that point B and moved it, and it did the slope calculations for me. And we figured out that the tangent slope should equal 2. And that's just the answer from the numeric calculations in the last video. But I want to hold on to that because that's going to let me know if I do this right. So as soon as I'm finding the slope of a tangent, I'm going to use my limit definition. Now, a is always the x that you are interested in. So in this case, because they told me x equal to 1, that's my a value. I like to do all of my work off to the side. Some people do it inside the formula, and that's okay. But I'm going to find f at a first, which is f at 1. And don't forget, we have an f at x defined. In this case, it's x squared plus 1. So in this case, that's going to give me 2. F at a plus h becomes f at 1 plus h now. You're never going to be able to fill in a value for h because h is going to approach 0. We can't just put in 0 right away or we lose the essence of this slope formula. But I'm going to do 1 plus h squared plus 1, x squared plus 1. Remember, when you're foiling or squaring a binomial, it's not just square the things inside. If you write this bracket out twice and FOIL or shortcut, whatever you're comfortable with, it should give you 1 plus 2h plus h squared. So all of this comes from foiling that. Then I have my plus 1 at the end, and I'm going to do one more thing. I'm going to collect like terms. So 1 plus 1 gives me 2. Now I'm going to come up and fill in. I have to keep the limit notation because that part is important, 2 points becoming 1. But now this is my f at a plus h. So I have 2 plus 2h plus h squared. Then I have my subtract, and this is my f at a, which is 2. And that's all over h. I'm going to clean this top up a little bit. I have a 2 subtract 2, so that gives me 0. And now I have to calculate this limit. This is an indeterminate limit. It always will be because you have h on the bottom, and we always want h to go to 0. When we were calculating limits earlier in this unit, x could be 2, 3, whatever made the bottom. But now the bottom equal to 0, so you couldn't determine it. Now that we're working with the limit definition, we're always working with h as it approaches 0. So I have to use one of my strategies. Remember, we had factoring, rationalizing, change a variable, and one-sided. In this case, I'm going to use factoring, and I'm going to common factor out an h from each of the terms on top. So 2h divided by or factored out in h is 2. H squared divided by or factored out in h is h. Now I have the times h and divide h, which I can cancel as long as h is not 0, but that leaves me with something that I am able to sub in, or I'm able to sub 0 into, so this becomes 2 plus 0, which is 2, which does match the answer we expected based on the video. So the slope of the tangent is 2. Now, I'm not going to do any more examples because we've already gone over all the strategies. What's really important is that you remember to do this and find your f at a plus h and simplify it, carry it in, and then you're going to choose a strategy based on what you're left with. In this case, we chose factoring because that's what we needed to do. You may need to rationalize if there's a square root involved. You might have to use one-sided limits if there is an absolute value involved. And if you have some really funky exponents like 1/3, 1/2, sorry, not 1/2, but 1/3 or 1/4, you may have to use change of variable. So you're going to pull together all of the strategies we already discussed to take a look at your homework. But I can offer individual help. Just email me with questions.